Hello, kindergarten teachers. Let's have a look at some ways that you can connect computer science into your energy unit. So you already know that the computer science curriculum in kindergarten is all about instructions. Children are expected to interpret instructions in various learning environments. And the lovely thing about instructions coming up in almost every line of your computer science curriculum is that you have lots of opportunities to connect this into your daily classroom routines and your other classroom lessons. So whether we're looking at following instructions or looking specifically at ordering instructions, we can find lots of opportunities to do this throughout your day and your year. So in kindergarten, we're talking a lot about instructions when we're looking at the knowledge, understanding, skills, and procedures. But the big idea, the organizing idea that exists all the way from kindergarten through grade 6, those common threads that tie everything together are the ideas of computational thinking, design thinking, and creativity. And these three pieces come into play in the cusps that you see in your computer science curriculum and then all the way up through grade 6. So anytime that you can have students practicing skills that are connected to computational thinking, design thinking, using their creative thinking skills, you're also building in some foundational pieces for the computer sciences curriculum. Let's have a look at your energy curriculum and some ways that you can connect those computer science cusps in nicely. We're talking about movement in energy in kindergarten and how we can move objects around in a variety of ways. So if you are using little robots in your class, you would have some excellent opportunities to have students move the objects, using the directional arrows on the robot or on the little remote control, depending what type of robots you have. We are communicating a sequence of 2 steps, which comes right out of the computer science curriculum. In fact, it would definitely be more than 2 steps your students are capable of putting in order when we're talking about little robots, or even if we're doing unplugged coding or doing these kinds of activities digitally with Chromebooks or on the smartboard or something. An activity like this where we're looking at moving the bee to the flower and then over to the beehive, and students are going to either draw these arrows, maybe they have cards with the arrows, so they're going to be thinking about how the bee is moving and also putting those instructions, putting an algorithm together using the arrows. And if we're doing, say, this activity with the bees specifically, and students have been using this top set of arrows and the bee is moving around this way, we can develop into sort of the next level skill and talk about, well, when we move around, if you were going to give, a human those instructions, do we move around in that way? And talk into, well, we make a turn. So a turn is a step that can happen in a set of instructions when we're talking about moving something. So we can, develop that computer science skill, we can extend it up, and we're talking about moving objects. And we could be moving little physical things on a checkerboard, and this is one way that objects can be moved in a variety of ways, and we're also connecting in that computer science. And if we get into talking about different types of objects and whether they move or they do not move, we're going to be doing our computational thinking. So while you don't see any skills and procedures that specifically say computational thinking within your curriculum, working on the different parts of computational thinking, practicing those skills is going to also help students be better at doing the skills and procedures that are in the computer sciences. And it's going to help them for when they are expected to actually understand the components of computational thinking in older grades. So just by doing the skills. So if we're doing a sort, we're talking about, identifying objects that move and don't move. So we will have some objects that we're considering, and we are breaking down. We're going to decompose those objects into their different parts. We're going to look at the different attributes, and in this case, we're decomposing into whether the object moves or not. So we're not worried about the object's use, and we're not worried about the object's color or size. We're only concerned about whether or not the object moves. So looking at something, determining, does it move, does it not, recognizing that maybe we start to see patterns like round things will roll, where flat things will not, and we can start to make connections between things that move and do not move. And then for abstraction, if we're getting right now down to sort these objects out, we've looked at all of their properties, we've now abstracted, and we know that all we are looking at for these is if they move. I really maybe don't even need to know what the object is. If it has these certain attributes, I can tell that it does move and it belongs in this category. So that is computational thinking comes directly into play anytime we're looking at specific attributes or properties of objects, ideas, concepts. We're going to be, that's that decomposing piece where we're looking at those different properties or attributes. And pattern recognition is anytime we're looking for similarities and differences and connections and how things are the same, such as that they can all move. And abstraction, that's simplifying. Can we generalize this into a category of things that move? And then you have the opportunity always to add on algorithm design. You can do it very specifically. Students, could we come up with some instructions that would tell a machine how to sort objects into these two categories? Or it can be just more generic and organic in the classroom and saying, okay, students, this is our job. Tell me what the steps you're going to take are. Can you explain the order that you're going to do these things in? And this could be, this sorting activity. This could be a hands-on experiment that we're doing in class. This could be in connection with having a discussion. Anytime you would give the students that end goal and say, this is what we need to do, what do you think are the steps? You're going to be more than meeting those computer science outcomes. You're definitely going to be reaching that transfer level of those computer science skills, which will be really advantageous to your students in the future. So if I can't see, we don't see specific sorting things. Now we could, depending with these different skills and procedures here, when we're looking about animal movements, again, we could definitely be doing some of that attribute recognizing and decomposing and looking for patterns. Again, that abstraction piece, if we're looking at how an animal moves, we don't care what species it is, where it lives, what it looks like. The only thing that we're looking at right now is how it moves. Identifying is bringing in those thinking skills. So I know certain attributes. I know that these attributes belong to this type of object, and these attributes belong to this type of animal or movement, pardon me. And how I can identify that is, by these attributes, and I can ignore all of the other things that don't matter, and I can show you that I can identify this. So that computational thinking practice, even showing that they know to some degree, is going to come into play when we're turning around and showing that we're able to identify something based on the attributes or those properties that we've learned about. And examining is definitely getting deep into critical thinking, thinking about why, so we can get some of that creativity in here, and recognizing that we're considering things beyond what we are specifically familiar with, and examine why movement happens in different ways. We can jump into algorithm. Again, just by asking students, can you think of a rule or instructions for, say, crawling? what identifies crawling? Can we come up with an if it does these things, then it is crawling? So that is, that computational thinking piece. Anytime the students are completing some type of activity, experiment, discussion, you're talking instructions. You're always giving them steps of things to do. So them following the instructions you've gave them, having them involved in creating those instructions. Like I say, here's what your end goal is. Can you come up with the process that you need to get there? Even just repeating back instructions that you've given them is going to be connecting in and showing you all of these computer science skills and procedures. That is a few ways that you can connect computer science into your energy unit. I hope you enjoyed.